Hello, myself Dr. Ajay Kumar Sharma from Hindustan Institute of Technology and Management, Agra. And this lecture we are going to be uh, go through the electromagnetic theory, which is represented here by the Poynting theorem and Poynting vector and its physical significance. Normally, the electromagnetic theory deal with the nature and the mode of propagation of electromagnetic wave, you can say. It is given by the Professor J.C. Maxwell in 1964. That is combining the four equations, one from the Gauss law of electrostatic, Gauss law in magnetism, and Ampere's circular law and modified Ampere's circular law and Faraday law of electromagnetic induction. In the electromagnetic wave, the energy is going to be contained or reside in it. It is going to be exist, stored and transferred to the medium. It is obtained or observed by the Poynting theorem or Poynting vector. So Poynting theorem and Poynting vector is going to be very important role regarding to Maxwell, regarding to electromagnetic theory, which is given by the Maxwell equations. Now, in this theory, the electromagnetic energy, total electromagnetic energy, which is given by the Poynting theorem, and this is given by the total energy, which contains the two type of energy. One is electric potential energy, second is a magnetic potential energy. Electric potential energy is defined as UE, and it is going to be half of the integration of over the volume. For arbitrary surface, it is E dot d dV. And similarly, the magnetic potential energy is given by Um and going to be defined by half of the integral of over the volume H dot B dV. E is a electric potential, D is a displacement vector, H is a magnetic field intensity, and B is a magnetic field density. It is the total energy in electromagnetic wave is going to be defined by adding these two energy. Okay, now these two energy is going to be defined by the Maxwell 2 equation, which is obtained by the Faraday electromagnetic induction, and last is modified Ampere's circular law. With this two, we are going to be solve this equation by putting this value, and we will find this equation. This is given by like that. It is integration of del dot E cross H dV is equal to integration over the volume minus del upon del T, half of the E dot D plus H dot P. This is the electric energy, electric potential energy, and this is the magnetic potential energy, which is exist inside the electromagnetic wave, and this is minus integral volume of V E dot J dV. Now this can be defined as by using divergence theorem, removing the divergence and converting to a surface integral E cross L. This is known as a Poynting vector. Okay, now the electromagnetic energy crossing the closed surface area per second, it is defined by this vector. Okay, the rate of energy is transferred into electromagnetic field through the motion of free charges. It is related with this vector. Okay, now this is overall interpretation of you can say the different terms, such as this first term, this is first term, this is second term, this is third term we are considering, and we will interpret it one by one. Now first term interpret, that is the total energy which is inside a electromagnetic wave. It is going to be obtained by the integral of V J dot D, which is the total energy due to the electron motion. Since this is the current density which is related to the electron, like that. And so whatever the energy is consist inside the electromagnetic wave, it is defined by this equation. Okay, now the total energy which is contained inside a electromagnetic wave in terms of electrostatic potential energy and magnetic energy, which is given by the second term. And in third term, we will qualitative analysis of electromagnetic energy is going to be flow through any medium and a closed loop surface. It is defined as S, which is known as a Poynting vector, and it is defined by E cross H. Okay, now combine these all three terms is also known as the Poynting theorem. And this physical meaning of this theorem is going to be time rate of change of electromagnetic energy within a certain volume plus time rate of change of energy flowing through the boundary surface is equal to the power transfer into a electromagnetic field. And this is the Poynting vector which is defined over here. S is equal to E cross H. It is a curl of electric field and magnetic field. It is defined by Poynting vector. Now the Poynting vector is defined with its complex form, and like that. And due to this, we can find the average electrostatic energy density. We can find out UE is equal to half epsilon E square is equal to half epsilon E dot E star. Okay, and there is a E star is going to be complex value of electric field. Similarly, we can define the magnetic energy density. Now, the Poynting vector application is going to be very important. This is the in coaxial cable, how the energy is going to be radiate from one place to another place, or going in a medium from one point to another point. It is going to be very important, and we can define the energy propagation inside a coaxial cable by the Poynting vector. Okay, like that. And the Poynting vector in plane wave can also be defined as simple way. When they provide the energy, the charges are going to be flow through it, and due to these charges we are defined the current in a circuit. If there is a capacitor is there, some resistance is there. Now there is a due to displacement current, the charge is going to be one flow through it from one end to another end, so the current is going to be obtained, and it is given by the Poynting vector in a plane wave. This is going to be in propagation of sinusoidal electromagnetic wave, plane wave in a fixed frequency. The Poynting vector is defined as. Now, one of the very important aspect of this Poynting theorem, it is not applicable for the constant field. Means if there is a constant field is there, so we cannot define the Poynting vector. There is some example related to the Poynting theorem, and we will analyze with the numericals, so we can understand it in a very good manner. Okay, a student may go through these examples and understand it by solving it and doing practice with it. They can know much more about the electromagnetic field. Okay, that is the few theorems are there which is going to be combined and produce the total electromagnetic wave and related to it. There is some references over here. You can go through it and find the more suitable solution and your problem. Thanks. That is the overall.